All right, let's help you out with some of these homework problems. How'd you do? The first one, you want to subtract the exponents. Now, you always subtract top minus bottom. It looks like that's going to give you 8/4, which is really the same as 2. Now, be careful, that means the exponent's 2, so it's 5 to the second power, 25. The second one here, you want to add the exponents. That means you add the numerators. You get 4/8, which of course is the same as 1/2. Now, it would be 36 to the 1/2. That's the same as doing the root of 36. We call it the square root of 36, so that's going to come out to be 6. With this problem, it might seem a little bit intimidating. The numbers are big. You don't know what this root, this exponent. Well, don't bring it in yet. Just actually divide 240 with 15. It turns out that if you divide those numbers, you get 16. And 16 to the 1/4 power is the same as doing the root of 16. Now, it's the fourth root, so you're looking for 4 numbers that multiply to be 16. That would be 2. Good example of adding the exponents. If you add the exponents, you get 6/3, which is the same as 2. So, same answer here as the one up above. Comes out to be 25. Now, with number 5, you'd want to subtract the exponents, but one of the exponents seems to be missing. Of course, we assume that it's 1. So it's 1/2 minus 1. You always subtract top minus bottom. Now, the number 1, I want to think of that as a fraction with a common denominator. I want to think of that as 2/2, so I can actually subtract. So when I actually subtract, I get -1/2. Now, it would be 3 to the -1/2, but the thing is that we don't want to have negative exponents. So what are you going to do? Well, you're going to flip your base. So that's going to actually produce 1/3. Now your exponent is positive. Now, if you want to write this as a radical, you actually would have to then continue to change and write this as the square root of 3, because, of course, square root is the same as a 1/2 power. But you're not allowed to have a square root in the denominator, so now I got to multiply the top and bottom by more denominator. How much more? Well, I want to end up with 2. I already have 1, so we're going to have to multiply by 1 more. If I multiply this, I end up with a √3 in the top, and I end up with a cancellation, so just a 3 in the bottom. Interesting, that's actually the same thing I started with, just in a different form. This problem is really just like a giant circle. It's just to help practice the rules of subtracting and then rationalizing. Ooh, negative exponent. Well, you flip the base. Yep, even if the base is like a fraction already, I flip the base. And when the base is flipped, then I end up with a positive exponent. Of course, positive 1/3 in this case. Now, if you bring in 1/3, that's like doing the root of each of these numbers. That's like doing the third root. Well, the third root of 125 would be 5. The third root of 64 would be 4. Okay, that's because 5 times 5 times 5 is 125. And, of course, 4 times 4 times 4 is 64. So the root comes out to be 5. The root comes out to be 4. 5/4. It looks like that the only thing you can do with this problem is apply the exponent to both of these. Now, when I apply an exponent of 1/2 to an x, nothing really happens. But a 1/2 to a 4, that's like doing the square root of 4. So that's going to come out to be 2. Since I want to write the answer as a radical, then I should change the top one also to be a square root. If you apply this exponent to both of these, you actually apply it to the 16. That's like doing the root of 16. The fourth root of 16 is 2. If I apply the exponent to the x, that's going to give me a multiplication. So I take 2 times a fourth and get 2/4. Well, that's the same as 1/2. So it's 2x to the 1/2. Kind of the same thing with this problem. Do the root of 216 and also apply it to the 9. Now, the root of 216, that would be 3 numbers that multiply to be 216. That'd be the number 6 if you check that out on a calculator. If you multiply the exponents, you get 9/3, but 9/3 is just going to simplify to be 3. So we get 6r to the 3rd. Now, in a problem like this, the b's are the bases that are the same. So that 3 that's out here, honestly, that 3 is just going to tag along to my final answer. But it's my b's that I want to try to add the exponents. Remember, you add the exponents when you have the same base. Only problem is I can't add unless the denominator is the same. So I want to multiply by 2 so I can get a denominator of 6. I want to multiply this by 3 so I can get a denominator of 6. So I change my fractions to be 3/6 and 8/6, which if you add them together is 11/6. Now remember, that is going to be the exponent answer on B, and since we want to write this answer as a radical, then we want to flip this to be the root of B, the 6th root of B to the 11th power. Okay, yes, we have a negative exponent, but I would suggest that you first just bring these exponents together. How do you bring them together? You multiply. If you multiply, you get negative 6 over 2, which is the same as negative 3. Now that I have this written as one exponent, I can do the business of flipping this p, and if you flip the p, you get 1 over p. But the exponent becomes positive. So it's 1 over p to the 3rd power. Don't change that to like a root of p, because it's not it's just a whole 3. It's not a 1 over 3. So we don't want to write this as any type of root. We're just going to leave it as 1 over p to the 3rd. And finally, for this last one, you divide the numbers. If you divide them, you get 2. If you subtract the exponents, you always subtract top minus bottom, you're going to need a common denominator of 2. So I have to multiply by 2. I have to change this to 4 halves. But when you do the business of subtracting, you get 3 halves. Now, that's going to be the exponent that goes on x. There's not 2 x's anymore because we combined them to be 1. But since we want to write the answer as a radical, then I'll let 2 be the root. So we call that a square root. I don't actually have to write that. And I'll let 3 be the power. So we have 2, the square root of x to the 3rd.